Okay, audio test. All right, we're looking good. So let's get started. Ladies and gentlemen, welcome to the Discourager of Hesitancy. We are continuing the work we started yesterday with batch texture quads. We kind of cobbled something together from the batch ColorQuads and the TexQuad classes, kind of a mashup of those two, but it's not right yet. And it's going to get more complicated as we go. So let's get our favorite beverage ready so we can get to work and lay out our plan. Today I have an alarm set for 15 minutes before the end of stream so that we can do our weekly analysis of progress. I actually found the numbers fascinating from the first 4 weeks of streaming. Literally every line in this, since we started streaming, has been on screen and typed on stream. So being able to keep track of your project time that way, it's very nice. All I have to do is go back and look at a stream timestamp and I know how long I worked on the project. So it's kind of handy that way. All right, so today we got a good start on the batch texture quads. This one. Today, continue batch texture quads. Now, first thing we need is a new shader with multiple textures. We're going to set a size to start with, and we'll go up from there if we need to. Got this part done. We've got the quads working. I would like to embed UV data in our image warehouse, which would essentially give us a tile sheet or sprite sheet like option. So what images do I have? Assets, images. Not very many. Maybe we hack together a quick book as a journal. That at least would be similar in size to the logo. So one of the ideas I've got for embedding this data is after you declare these two, you may hit UV bracket some label like maybe it's run 01, and then you get a pair of coordinates, integer, it's like 0, 0, 0, 0, 0, 0, 0, 0. Which is of course not right at all. It would be like 10 and 10, 10 and 10, 0. Something like that. Maybe we even have like a UV with a different, let's see here. Maybe it has to contain a vector2. Vector2 for the XY, right? I'm just trying not to make my... Right now, I do not want to deal with complicated file formats. Again, we're not using any more libraries. We're not adding any more dependencies today. We never will, hopefully. So if I can parse this with just like fscan or sscan, that would be perfect. Or just go with rectangle xy width. Height would often be very convenient. And it would basically compute these from the same thing. And these are going to be in pixels, which is not what UV coordinates are actually stored as, but we can derive it when we dump it into the warehouse, so I'm not worried about that. Integers are easier to think about as a human. Hey, these 4 pixels over here, these belong to that. You know, integers work better for human readability. Eventually, maybe we'll do do a more thorough data processing, but this is all not game elements, right? This is outside of game elements. So it's okay if it's hacky, because I'm the only one using it. So that is an idea. Let me go drop that in the journal. The to-do list, rather. Those are a couple of good tech debt items. Tech store UV data in image warehouse. They might look like that. Or this one. Something along those lines. Okay. Back to our journal. I'm going to start with this. And then I think we need to embed UV data next. Make our texture handling even more powerful. What else? We do have those other 2 tech debt items near the top that we could tackle. I don't want to tackle this today because I basically need to implement a bucket array. This one we could do reasonably well, reasonably quickly. But really, batch texture quads are pretty close. Array of textures. Look for empties. Warn if full. If it's full, like we're going to start with having 4 texture slots. I did have a printout once of how many texture slots each fragment shader can have, based on my graphics card. But I mean, we're going to start with 4. We should embed another. Hey, Ella Tyler, how's it going? Follow me on Twitter, thanks. Yeah, I'll take a look at your Twitter and see if it's of interest to me. Thanks for the follow. It's appreciated. Okay, so let's go grab a texture we can add in to our images, just so we have. We'll put the green eggs one back in. So I'm going to active projects, word sleuth, assets, images. We're going to go get the eggs back. Okay. Let me look at this one versus this one. Right, so I'm going to just copy an extra image over that's not too big. This is only for testing. It's not going to remain in game. Compile. This one is make build target equals embed PNGs. I think. Shoot. Oh. It's in tools. There we go. Tools, binary dot slash embed PNGs. We added the new icon. Great. And now, good worse. Now, sandbox, when we're actually testing this batch texture quads. Oh, I don't remember another thing we need to update eventually. Define class update rectangle from batch quad classes, which are texture and ColorBatchQuads. Okay. So which one do we do first? Let's put this under tech. Let's not deal with that today, unless we feel like it. Right now, it doesn't affect anything we're doing. So first, we need an array of textures in our class. Let's do it that way. So, texture quad batch. Instead of a texture, we're going to have yours, and we want actually an array of pointers. This is going to be static constant num textures equals 4 num textures. There's a texture. I'm trying to remember what a texture. Bind, unbind, width, height. I wonder if we can just capture the image index. Texture.cpp. if we load in based on name, we get the image index. So anyway, we load a texture except for from buffer. Oh, we do have image index. We do store that. Why is that not accessible? I actually do want texture. What was our texture store looking at then? We get it by index. I would actually far rather look them up by index than by name. I would favor, instead of looking up the string from the index, I'd rather look up the index from the string. Do we add that to our tech debt? Just a second. All right, my son was into things he shouldn't be, and nobody was coming to take a look. Texture class should texture store should look up index from key, not from index. And then our texture we're going to add the ability to look it up our number. Right there. Image index. Okay. Okay. Very good, I guess. And by default, it'll be all null pointers. Or we can initialize it in our constructor. our textures. We're going to equal our texture pointer is going to be no pointer. There we go. Okay, so that's the easy part. Now, when we set quad texture, textures, if equals null pointer, I think. Okay, so now there's really only one we have to update. Okay, so we're gonna say if textures at index equal to null and what? Let's not fiddle about here. Our temporary texture is not equal to null. And our temporary texture index is equal to our texture index. Already have this texture. Else, we don't need to do anything. Index equals index and break, meaning we already have it, we don't have to do anything else. If x index is less than 0, then we have to do something else. So like we set all the quads to the same index, to the same texture. We'll really only look it up once, and then it won't add any more copies of that to our array, so that's good. If we don't find it already, then we need to find a place to insert it, which is this part here. we don't want to do this yet. Actually, do we? No, because we already know it's null. That's fine. Pardon me. So if we get through both of those and say there is not a real, we already have this texture, or we added this texture, neither of those resulted in having a texture. Let's make it a warning for now. Now let's make it an error. TexQuad batch. Set quad text. Could not add texture, no more room. Already have textures. One last thing we have to do here. All right, so how are we going to do this? One, the quad need those two pieces. Vertex offset can be 0. Fine. Correct. I think this as well. So you're going to be working in this quite a bit. Okay. Okay, problem 1. basically means remove the texture. No, we should just assert. Okay. Okay, so we have a current texture index. We want to walk through each quad at the same vertex offset. We're going to now walk through every quad. Int x index count equals 0. We get our Q offset. We get our quad text index. If Q texture index equals the current texture index plus plus texture index count. If texture index count less than or equal to 1, right? If this is the only quad that references that, then we can remove it. So textures. Oh, that's not quite right, is it? Oh no, this is right. Sub texture index count or current texture index texture index count is less than or equal to 1. Null it. The texture itself is owned by the texture store, so I don't have to worry about cleaning up. Where else? Okay, so here's another question. If current texture is the same as the new texture, do nothing. Okay. If underscore textures at the current texture index these are not texture indices, these are texture slots. Since the texture store ensures uniqueness, we can just do a pointer comparison. We do not have to look at the contents at all, because we can only have one copy of any given texture. Texture in the current slot equals our new texture. So for whatever reason you have people which also means up here text slot. We need to have these as -1 to start with. Because these have not been set. When we initialize the buffers, they've not been actually assigned a texture. Yeah. Okay, remove the current texture if needed. See if we already have a copy of the new texture in here. See if we can insert the new texture. Otherwise, if we've done all that checking, we should be good. Texture index. Or vertices per quad. Otherwise, update the texture slots in the vertex buffer. Q offset. Computer int vert offset equals basically entries per vertex. Index times entries per vertex vert off the offset. Equals float of index, except I decided I did not like calling text index. We're going to call it text slot because that is more appropriate. The texture indexes are indexed into the image warehouse. Is that it? Set. I think. I feel like I'm missing something. first of all, if our current texture is equal to the new texture, we don't have to do anything. Literally, it's a no op. 2. Remove, so we get an count. So texture, okay, we're going to change the name of this. This is with texture slot reference count. How many people are pointing at this texture slot? Then our quad offset. Doing invert offset, it is always 0. It's more consistent with the above code. Invert offset equals 0. And here, okay. It's basically useless. It's a no op plus 0. Okay, so we go through every quad and we just look at the first corner. Since we are setting quad texture coordinates as a group of 4, I can check just the first one. I don't have to check all 4 vertices. So we increase our texture slot reference count. If it's less than or equal to 1, we can clear that texture slot. Cleared. And this is not a problem because we've already compared. So we can't remove the current one and put in a new one. We can't remove the old one and put in the new one in the same operation. So that's good. We walk through get it. If it's not null, and if the we don't even have to do that. We can just do pointer comparison. So that should be fine. We don't even have to check for null anymore. We assert that our texture is not null. Therefore, if they're equivalent, we already have it. Okay. Simplification. Okay, walk through. If it's null, we can stuff it in there. Texture slot equals index break. If we didn't have room for it, so we've already inserted 4 different textures, we error out. That tells me that I need to add more texture slots to my basic operations here. Otherwise, no room for more texture slots. Consider expanding. Our default is 4, so. Each quad. Calculate our offset. For each vertex in that quad, we compute our offset. For each quad, each vertex, we can go to the texture slot and set it. I think that's it. I honestly don't think there's anything more we need to do here. These fellas are, let's see here. Set quad corners, set quad rectangle. To do, we'll add this to our tech deck. TexQuad batch. Quad rect should just reference set quad corners. Okay. All right. I think that simplifies things quite a lot. So in our sandbox, we need, actually, not even there. Set quad rectangle, set quad texture of quad 0, 1, 2, and 3, because we're starting with 4 quads. Okay, one missing piece. We need to do the shader. And that is looking pretty good. Okay. Let me go on a restroom break here real quick. And we'll continue from there. Okay. Texture quad batch. So this old simple texture shaders will not work. So let's bring up all the references here. In assets shaders, texture.fragment. Assets shaders, texture vertex. I want to swap these around. Pardon me. Ooh. I want the vertex shader first, and then the fragment shader. Now this one is going to get back when I was doing OpenGL experiments. What's it called? Text. Batch texture vertex. Batch texture fragment. Oh. Okay. So here's if you're only dealing with one quad, one texture. Are these two here? We don't really need the texture slot. Over here, oh, no, let's not change these. Okay, so we're going to have to reorder these to match our vertex buffer layout. We need the UMVP still. This will go away. We will get color, texture coordinate, and in texture index, which we will probably call texture slot in our new one. Get our position, we pass along color, texture coordinate, and texture slot. Into here. Okay, so let's start doing this. Text, texture batch, vertex. Oop, not there. There we go. So in our case, color comes last. Get that. We do not. That. Position, vertex. We're going to move color down just so it's all in the same order. Text coordinate, text index, color. I think that's it. Text batch fragment.glsl. There are tons of things we could do to all these shaders and our shader handling to make it all fancy, but we're not going to. Certainly not in this game. We are keeping our scope as small as possible. We're going to allow 4 textures, because that's what we agreed on before. We get our texture index, which we're going to change the name of for ourselves. Here we are. Text index will be texture slot. I think that's a better naming. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so if we don't define a texture slot, it's less than 0. Good. Except I'm going to change things a little bit here. Instead of color being our fallback, we're going to multiply the color here. And this one will be a vec4. And we're just going to make it, what is it? Magenta is the red, green, blue, full alpha. I think that's what we want to do. In theory. So if we don't have a texture, it's going to be horrible magenta. If we do have a texture, we take it and multiply by the color. That way we can do things like if you pass in just a black and white thing and give it a color, we can do all sorts of things with the to set the color. per quad basis. Okay. I think that's it for the shaders. I think that's all we need to do. I have a weekend project I want to tackle. I've not had time yet. Mostly because my weekends are I can't do real work on a weekend. I want to make a canvas shader where I can pass in basically binary, like bit codes, and make it render things based on a couple of arrays we pass in. So we'll have to see. All right. Let me think. I think that's it. So let's go shaders text batch V, text batch F. Batch. I can see why in big games a lot of their shaders will be generated at runtime depending on the needs and then compiled on the GPU. So for example, I could see wanting to have your color, especially if you're gonna, let's see, let's close up some of the reference files we've got. Okay, I could see your texture being a single color like the text font. What did I call it? I called it text. The fragment shader. Basically, when you get a text, we've rendered our text to a packed texture. We declare that it's only the red channel. We only have one single value for the whole red channel, and we don't have to pack any more data than that. And when you want to set the color, it's based on the color uniform you send in. So I could see easily wanting something like this to take a texture that only has one channel. That way we are packing a lot less data. And just using that to set a color simply, but we're not gonna overthink it, I think. So we are in tools, we will embed shaders. And there's our new batches. We're going to go back to our TexQuad batch. We're going to load the new shaders. Batch. Make a, let's do it clean and debug. We're going to see what comes out. We can test one other thing all in one shot. Okay. Well, oh yes, that is true. We have to do some work in text batch still. So close. If we can multiply by color, we can do things like fade to alpha. We can make it like highlight, blink, red if you're doing something wrong. We can do a lot of things with that multiply by color. Default will be white, so basically play the current texture as is. TexQuad batch. So that goes away. Okay, so here's the code. Oh, we need to set dirty in here. This is the one time where we actually set the vertex buffer to be different. So that's the one time we need to update our vertex buffer. So that basically means we send a whole bunch of new data to the graphics card. We want to do that as infrequently as possible. So from here, we bind our shader, so that's fine. That goes away. What we're going to do is we're going to do for int index equals 0, index less than TexQuad batch, num textures plus index, if m_text textures subindex. We're going to change the name index to slot. It's not equal to null. Then m textures slot. Fine. Samplers textures okay. Shader, bind our shader. So we're doing that. We bind our textures. Our samplers are 4. So int samplers 4. That. Only reference the samplers if they're there, so maybe we don't have to do anything there. And we're just okay with this. Set our samplers. MVP, and then draw. So I think that's it. All right. Find our shader. Find our textures. Set up our samplers as a texture batch fragment shader. U textures for. Is our uniform for our textures? You do anything else there? Okay. Let's take a look. You're right, it's not. On texture. I just went through the process of defining that. Thank you. Here. Yeah, that is clearly defined. What is it complaining about? Oh, because I am, in fact, quad index. There we go. M shader was not initialized because we call it texture shader, which maybe we should rename that. Texture batch shader. Sure. Texture quad batch. Now, last thing in our sandbox. If we leave one undefined, it should show up as magenta. So we should see 2 texture slots and a purple quad. We could do a whole lot of premature logging to see if everything's working, but we're just going to run it. I'm going to go to sandbox. Well, there we have some issues, but this one is horrible magenta as predicted. This one looks, I wouldn't say right, but it is there. I don't know what's going on up here. And clearly, the Scourger of Hesitancy logo is not popping in right. So, now we log. not what I told you to do. I said go to the end. Okay. I actually really like this is super close. Texture quad batch. Let's go just log this stuff. We could all just also just run this in the debugger. See what's going on. The current texture slot is greater than or equal to 0. We can't remove a non-existent texture. Let's add more logging. Node. Set quad text of quad index. Current texture slot. Texture already exists in slot. Added texture at slot. Error. Otherwise. That texture quad thing to slot thing. In end matches current texture to right? Because we made sure that the new texture and the old texture. All right, let's just see what the debuggers with the command line debugger with the printf debugger. You know, a lot of people bash on printf debugging, but that's because they never did bare microcontrollers where all you have is a green LED. Debugging a green LED with no console output makes you really appreciate the finer things in life, like printf debugging. Okay. So, set quad text 0. We added a texture at slot 0. Set the texture in quad 0 to 0. We added the texture at slot 1. Here, texture already exists in slot 0. Set texture in quad 2 to slot 0. So that all should be there. So what have we done wrong? What did we do wrong? Okay, one other thing we can test in sandbox. We can actually set the same texture twice. How we get that log message. Get key from index. Another thing we can do real quick. Which might be convenient, is bool operator equals a const texture and other. I mean, we can add both of them. That is dead simple. All we have to do is return m_image index equal to other .m_image index and non-equals. We will get fancier as we go. This is basically preparing the ground for texture store to remove and add textures as needed. So being able to test for equivalency is always nice. Okay. Sandbox. Add texture at slot 0. Oh, texture already exists in slot 1. Oh, interesting. This setting quad text 1 to the same thing we set it to before. That should let me think. We're doing pointer comparison here. Texture will be underscore textures sub current texture slot dot total with name. New texture. Print out the pointer. Just something slightly unexpected is going on here. So we might as well be very explicit in what we're doing. Okay. If current texture slot greater than or equal to 0. Did I mean to use the prints? Yes, I did. How did they know? Nah, right. Lined everything up, but it doesn't matter. Let's see how that works out. We just fact we're not like site faulting and crashing. Okay. So we set text quad 0. We don't have anything in the texture slot for that quad. So we have our new texture, which has an address and a name. Added it to slot 0. texture in quad 0 set to slot 0. Then we set texture. Then we go to the next quad. The current texture slot is 0. I think it should be. Vertices at the quad at the text. Current texture slot. Okay, so this is where some of our issues are coming from, I think. Okay, and set texture in quad thing to slot whatever. M_textures sub hex slot. Take this for a test drive. We're gonna beat this before too long. I swear it's set the default slot to -1 everywhere. Okay. Current texture slot, new texture. We add the texture at slot 0. We set 0 to 0. This one has a current texture slot that is wrong. Current texture is what we set before. The new texture is this. We added that slot 1, quad 1 in slot 1. Wait a second. No. We do not need to walk through these quads. We're overriding our own quad information. We don't need Q offset. We need the quad offset we already calculated above. This one. There we go. Quad offset was not declared in this scope. I calculated it way. Oh, I did not calculate it up there. Quad offset. There we go. Is that better? Boom. Now everything's wrong. Perfect. Current texture slot minus 10. That doesn't even make sense. It should be minus 1. Set quad 2 already exists in slot 0, so that's good. Current texture slot 1, current texture, new texture, at least it's getting that match. Okay. This is the one that now causes me consternation. -1, -1, -1, -1. Where is 10 coming from? Vertex. In our vertices, we'll just do it this way. Current offset plus our vertex offset plus our textures offset. Equals that. Where's it getting minus 10? Current texture slot. -1, -10, 1, 1. Two should not have a texture slot. So what are we doing wrong still? Entries per vertex. Current quad offset plus the vertex offset plus the texture slot offset. Okay. Let's do some cheating. If odd index 0, we're going to log more things than we want to log. We're going to give each quad. Oh, wait. Indices per quad times X quad batch. Entries per vertex. Actually, yeah, that's fine. Log note quad thing vertex thing. Texture slot. So we're gonna get error. Q offset word, B offset, texture slot offset. Pass it as an integer. This will tell us everything we do before we start messing with the stuff. After it ends, we'll go ahead and log the status again. I think we're close. Of course, it wasn't defined until down here. Okay. Yep, so I'm gonna take a look and see. Enter our sandbox. What? Okay, so literal minus ones. That's fine. What are those 0? Index is 0. I print out all 4 quads. And for some reason, quad 3 is not initialized the same as the others. Okay, then we set quad 0. We set everything, and then we log all the quads again. And sure enough, quad 3 is just a bit of a mess. Then we set the other quads. So what happened to quad 3? Alright, we set the indices, not a problem. X, Y, 0, 0, -1 for each quad. Set the texture slot equal to -1. Huh. It's time to do a clean and build. Code does not say to set anything to 0 in the texture slot element of our vertex. But it is getting a 0 in that third one. I'm not sure why yet. Really wanted to spend about 3 hours today working on the embedding UV. I think that's going to add a level of convenience. That would be great. So why is quad 3, the fourth quad, not initialized properly? Before we have ever set a quad texture at all, it's full of zeros. Why? Unbelievable. Then we set quad 0 to have slot 0. Okay, look, it's like we said, quad 1 and 2 still have negatives. Quad 3, for some reason, has a texture slot 0. That should not be possible. Why would it lay out? The first 3 quads correctly, but not the rest. Am I doing something here? Set quad rectangle. Set quad text. Look, I'm not doing anything. Okay. Maybe before we set the quad rectangles, we set the texture. We did do a clean first. That's unfortunate. It'll take longer. Yeah, I'm not sure yet what is going on. Oh, well, there's the first one. That's better. I didn't change anything, did I? That's still 0. Afterwards, that's set to 0. Current texture slot. What is this garbage? Ow. Texture quad 1. Oh, okay. I know what's going on. I had to add Q offset. I'll bet. Q offset equals and add that offset to all the places it needed to be, or that extra factor on the offset. One of these days, we probably should change all our vertex buffers to actually contain structs instead of just arrays of floats. Oh. Okay. 400, 300. None of this makes any sense. This doesn't even match. Like this. This. Alright. Now. There's no 400 or 300 in here. Where's it coming from? Okay. Okay, so here's another problem. Anything that contains the word offset, we just need to make sure. Oh. Also, oh gosh, okay. We need to make some changes. The indices per quad is 6 because there's always 2 triangles, but the vertices per quad is 4. So that would also make a big difference. Hey, and that's very nearly what we want. The main issue now is this thing. So when we first start up, everything is -1. That's what we'd expect. Then we set, okay, so this is not what we expect. This is quad 0. We expect it to be the orange and red icon, because that's this. But at least the, see now, oh, well, let's see. Times TexQuad entries per vertex. Okay. Before we start doing anything, it's all -1s. We get our current texture slot at quad 0. That's -1, which we expect. Our new texture is something. We set it at slot 0, quad 0, gets slot 0. And still, this is garbage. What is this? This all should be negative ones. Two, quad 1, nothing done. Oh, wait, we're past that. Negative 1, negative 1, negative 1. Afterwards, zeros, negative 1. Okay. Quad 1 got slot 1. Quad 2, quad 1. Okay, so these should be the orange and red crowns. This should be the eggs. This one at least is right. Zero or quad index equals 3. So after the last one, we'll take a look. Oh, not 3. Oh, there. Okay. Just look at the index buffers after every quad set. Okay, all negatives. That's what we initialize to. We set this guy to zeros. Negative 1, negative 1, negative 1. This one should get slot 1, and it's not printing out. Why is it not printing out? Oh, good heavens. Here. All negative ones. 0 and 1s. Set quad 1, which gets 1. Set quad 2 to 0. Set quad 3 to nothing. Quad 2 should do nothing, because we already have the dough in slot 0. That all looks correct to me. So, question the first. Where's the crown? Why are these eggs? Text batch. Fragment shaded that gets it. texture slot. This is me being. No, never mind. It is being bound in that slot. Oh, it's not. There we go. By default, it's 0. So if you have a single texture, you don't have to explicitly state the slot. If we have more than one, we do have to. Now, magic occurs. Yay, we've got it. Done. Whew. That took me longer than it should have. Excellent. Boom. Done. Okay. Now, in our to-do, I have a tech that I want to enter. Tech that TexQuad and TexQuad batch. UVs are rotated, flipped. Okay, we'll take a look at that later. But now we need to clean up. There's nothing here to comment out. It's all in TexQuad batch. This whole thing goes away. Actually, I think there's one of those up here. We're logging, and we're no longer logging. Cleaning it up. That does leave us 3 hours to work on UV in the image store. It. Sandbox. Yes, nothing crazy. It's all there. Quit. Journal. New shader. Rip textures. Look for empties. Error if it's full. Move if possible. Okay. All right. Edit array of textures to TexQuad batch. When setting a quad texture, if texture is same as old texture, pardon me. If the texture already has slot. If texture can be inserted, be removed. Everything renders as expected. Boom. Shaders, images, journal to do. Image warehouse has been updated with a few nice convenience functions. Sandbox scene. Shader warehouse. Yep. Actually. Oh yeah. That all looks right. Get commit trim. Text that quad batch. Now working as intended. Okay. Nice. Okay. UVs. We need to have better UV handling. Pardon me. Allergies are going today. I don't want to do that today. It's good tech that we can handle. It's not rocket science. That's an easy one. That's also not bad. And all of this tech debt here would be something good to tackle. Before we go down the UV data. I'd rather tackle the UV data than the SPD containers. So yeah, lots of things happening around the house today. There were some crazy lightning strikes last night, started some fires. Most of them were put out, but there's still one. I guess it just jumped the highway not too long ago. So if I suddenly wrap it up, it'll be because of something like that. Which, of course, kids now have to be a little bit more limited, so they're acting up a bit. Um, let's do these two real quick. I don't think those will take long. Texture store. Oof, we're storing it all by string, which means we can't do, let's see, what other stores do we have? Shader store. Font store. Okay. Back to the journal. We're not doing this one today. I should look at index from key, not key from index, because the stores are going to use a bucket array instead of the map. Okay. TexQuad batch. Set quad rectangle. Compute all of those. Set quad corners. X0, Y0, X1, Y0, X1, Y1, X0, Y1. Boom. We can be much more selective here. Not here. Here. About this kind of stuff. And it's all just easy copy. Yeah. So we do not need those. We literally just compute our four corners. And so, file. We need to give it the quad index. This little convenience function, clean it up. Run it. Make sure we haven't broken anything. All looks the same. Great. Refactored TexQuad batch. Set quad rectangle to just all set quad corners. We do have cases where we want the quad to be not square, but most of the time it is. So we allow you to set the corners anywhere you like. But in general, the most convenient thing is to call set quad rectangle. So, okay, so there's that one. Two. Would like to know why TexQuad and TexQuad batch UVs are wrong. But I think we're going to do this instead. Real quick. Is it going to be quick? Just out of curiosity, ColorQuad batch. When we initialize, XY, red, green, blue, alpha. Well, there are some other fun little tidbits we can add to TexQuad buff. ColorQuad batch. Void set color. Make the greens back here. Or int index 0, quad index less than image quads, quad index, set quad color, to color. Done. Quad batch. All right, we're going to this is not going to be a fun one at all. That sets all quad colors. Okay. In color batch, when we initialize, this part's fine. Because for every quad, the indices are going to be the same. Okay. Then, basically everything from here down go to set quad rectangle x, y, width, height. Then set quad color at quad index to color of 255, 0, 255. I think that's going to be more convenient in some ways. Zero, 0, 100. Give a small space just so you can see between them. Okay, so I think that's going to simplify things a lot. Or set color Means method just does it. Okay. I think that's gonna work. Which we'll be able to see right away. The reason we're doing that is we're pushing everything into that set quad rectangle. Oh, yeah. Let's just do it that way. I mean, by default, nothing has to look pretty when you initialize it and then don't set anything useful. So it's shining up bright purple, should be just fine. Okay, all the buttons appear correct. These are using the color quad batch right now. This little trapezoid here is a quad, this little trapezoid here is a quad. So this is 5 quads, only one of which is actually rectangular. So we've obviously not broken anything there. That's good. Because now this class is going to tell a fine what the rectangle information update needs to be based on this. Do the same thing to TexQuad. Batch. When we initialize, we set the vertices, the indices, and basically from here, I kind of want to do the same thing we were before. Actually, let's set UV the same for all of these. Unless we set it to something else, it won't matter. Okay, so we're going to set the indices and the UVs to some default. Then everything else is going to be set quad rectangle. Zero, 0, 100, 100. Set quad rect R at quad index. We also need to do the texture slots ourselves. There we go. Just break it up this way. Okay, by default, everything gets that set. Therefore, r.x plus equals r.w plus 10. Now, we're going to set color all in one shot. Of 255, 0, 255. Just like this. Okay, great. Okay, so now all of our positional information is run through set quad rectangle in both of these classes. So in set quad rectangle, which is actually going to call it set quad corners, which color quad batch set quad rectangle is not being as good as it should be. Set quad corners, quad index x0, x, y0 here, x1, y0, x1, y1, x0, y1. All of that refactoring simplifies things nicely. It gives us one simple control path. What's this? Oh, that makes sense. Oh. Okay. Set quad corners. This is going to be an interesting one. Because we need to update Fine's rectangular information and potentially move the positions of other quads. So the brute force way is that no, not here. Parent class contains a rectangle that describes where we're drawing things. And that position in screen space is not the same thing as the local position we want to. So we're going to have, let's see, go to our scratch buffer. Let's talk about this. Each of these quads is like this, more or less. And if we add another quad to our batch, here's what we're trying to accomplish. Let me try and build up a reasonably coherent explanation. Oh, it was just drawing mode. I just never bothered learning it. Okay. We want a find to keep track of the rectangle enclosing all the points. So basically a bounding rectangle of all of these. The union. Mic is low. Thank you for the note. Let's see. I can turn the gain up more, or I can sit closer to the mic. Let me know if that's helping. Now, a find doesn't know anything about what we're doing to our vertex buffer. So when we update the vertex buffer, we have to report back to a find what we've changed. So that a find updates its rectangle accordingly. Okay, so we want a find to keep track of this outer rectangle and each quad inside. And have its points be just about anywhere, actually. Quad 2. Quad 3. Close beard nerd whisper ASMR. Yeah. Is that how I need to advertise myself? An ASMR coder, just turn the volume down real low. So is it not better? Let me check the phone real quick. Okay, better still low. Let me. All right, I have max gain. This is max gain right now. All right, so that call was from a friend, and there were some lightning strikes last night, which lit some fires. Most of the fires are out, but one of them is still burning, and it's burning close to his house. So I'm gonna go get his kid, bring him back to my house for a little bit, and then I'll be back on stream. So unfortunately, we're gonna have to pause this discussion. Save up your questions. I'll be back on stream in, I don't know, half hour, 45 minutes or something. So yeah, catch you all later.